Welcome to Learning with Philemon. In this video, we will be looking at the oxidation of alcohols. In the previous video, we learned that alcohols are organic compounds that contain a hydroxide OH group. As can be seen in methanol, one carbon has a single bond to oxygen. The process of oxidation can be defined as when a carbon gains more bonds to oxygen. Before we start looking at these reactions, we need to distinguish between primary, secondary, and tertiary alcohols. A primary alcohol is an alcohol in which the carbon bonded to the OH group is bonded to 0 or 1 other carbon atom. In methanol, the carbon bonded to the OH group is not bonded to any other carbon atoms. In ethanol, the carbon is bonded to 1 other carbon atom. A secondary alcohol is an alcohol in which the carbon bonded to the OH group is bonded to 2 other carbon atoms. This can be seen in 2-propanol. A tertiary alcohol is an alcohol in which the carbon bonded to the OH group is bonded to 3 other carbon atoms. This can be seen in 2-methyl-propan-2-ol. The oxidation reactions will differ depending on whether the alcohol in question is primary, secondary, or tertiary. Let's begin by looking at primary alcohols. To oxidize primary alcohols, you heat them up with an oxidizing agent, such as potassium dichromate VI, K2Cr2O7, or potassium manganate VII, KMnO4. An oxidizing agent oxidizes other substances, but is itself reduced in the process. For more on this, please watch the videos in the Redox playlist. Primary alcohols can be oxidized to aldehydes. In the example below, we see that ethanol is converted into ethanal. In aldehydes, the carbon at the end of the carbon chain has a double bond to oxygen. This is classified as an oxidation reaction as this carbon has gained a bond to oxygen. We went from a single bond to a double bond. Note that the ethanol molecule loses 2 protons, H+ ions, in the process, although this is not always shown in the equation. The aldehyde can be further oxidized to a carboxylic acid, in this case ethanoic acid. In carboxylic acids, the carbon at the end of the carbon chain has a double bond to oxygen and is also bonded to an OH group. As can be seen, the carbon now has a double and a single bond to oxygen. Note that as the carbon gains more bonds to oxygen, it loses bonds to hydrogen. We can control whether we get an aldehyde or a carboxylic acid depending on whether we use distillation or reflux. If we want to convert an alcohol into an aldehyde, we use distillation. The primary alcohol is heated with the oxidizing agent in the round bottom flask. Aldehydes have lower boiling points than alcohols. Alcohols have higher boiling points because they can form hydrogen bonds due to the presence of the OH group. For more on this, please watch the intermolecular forces video. As the aldehyde forms, it boils. The aldehyde vapor rises and condenses when it hits the colder glass of the condenser. The condenser is cold because cold water is run through its outer part. The aldehyde liquid then trickles down into the receiving flask. If we want to convert an alcohol into a carboxylic acid, we use reflux. As before, the primary alcohol is heated with the oxidizing agent in the round bottom flask. However, this time, the condenser is placed vertically above the flask. When the aldehyde vapor condenses, it trickles back down into the round bottom flask. An excess amount of oxidizing agent has been added so that the aldehyde is oxidized again to a carboxylic acid. Note that the oxidizing agents are reduced and as a result change color during the reaction. Potassium dichromate VI changes from orange to green. Potassium manganate VII changes from purple to clear. Now let's see what happens to secondary and tertiary alcohols. Secondary alcohols are oxidized to ketones. For example, propan-2-ol is converted to propanone. Note that the second carbon loses a bond to hydrogen but gains a bond to oxygen. In ketones, a carbon not at the end of the carbon chain has a double bond to oxygen. Ketones cannot be oxidized further using potassium dichromate Vi or potassium manganate VII. This is because carbon cannot bond to any more oxygen atoms without breaking carbon-carbon bonds. Breaking carbon-carbon bonds would require more forcing reaction conditions. Tertiary alcohols are not oxidized at all by the aforementioned oxidizing agents. Similarly to ketones, in order for tertiary alcohols to be oxidized, carbon-carbon bonds would need to be broken. In summary, primary and secondary alcohols are oxidized by the following oxidizing agents. Primary alcohols can be oxidized to aldehydes or carboxylic acids. Secondary alcohols can be oxidized to ketones. Tertiary alcohols cannot be oxidized using the aforementioned oxidizing agents. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.